Hola, boys and girls. That means hello. How are you doing this morning? I hope you've had a wonderful morning so far. And I just want to get us started on some warm-up problems for today. So let's go ahead and look at our DMA for week 35, day 3. And our first problem is going to be an elapsed time problem. Remember, elapsed time means how much time has passed. So sometimes if we know the start time and the end time, then we can figure out how much time has been passing in between those two times. In this case, it says Jason gets up at 7 o'clock. He takes 15 minutes to shower, 5 minutes to brush his teeth, and 20 minutes to eat breakfast. What time is Jason ready to go to school? So this tells me that we have the start time, we have some time that has elapsed or passed in the events that he's done for that day, and now it's wanting us to find his end time. What time is he ready? So I'm going to go ahead and take a piece of paper, and I'm going to use that paper to show a timeline. Now, when I do that, I need to, basically, I'm using a number line, but with time. So I'm going to use my start time, which is 7 o'clock. Remember, this is going to be in the morning, since we're getting ready for school. And most of the time, people are getting ready for school in the morning. And we want to know what the end time is going to be. What time is he going to get ready or be ready? So first thing we know is he took 20 minutes to take a shower. So we're adding on, 15 minutes to take a shower. 15 minutes to take a shower. So that tells me that we are going to add on 15 minutes to 7 o'clock. Now, when we add on 15 minutes to 7 o'clock, there aren't any minutes here, so we're going to make this 7:15. The next thing is he took 5 minutes to brush his teeth. So let's add on 5 minutes to 15, which makes 7:20. And finally, we're going to add on 20 minutes for him to eat breakfast. Okay? So we could do that by adding 10 and then 10 more. So we could go 10 and 10. So this could be 10 and this could be 10. And that would be 7:30. And then 10 more would be 7:40. Or we could just add on the full 20 minutes onto 7:20 to 20 more would be 7:40. So it all depends on how you want to break it up. It's up to you. Sometimes it might be easier to add 2 groups of 10. It might be easy to add 1 whole group of 20. But the time that he would be ready for school is at 7:40. So I'm just going to bring my sheet back over here. And this is going to be 7:40 a.m. And please make sure you're showing your work. You have plenty of room on the back here to show a timeline. So please make sure you show a timeline on your paper somewhere. You might be able to even show it up above, which you might be able to show it up here if you have some room. All right, our next problem is comparing 2 fractions. Remember, your denominators right here tell us how many parts are in the whole. How many parts has the whole been partitioned into? So if I have a whole here, I have 1 whole, and I'm just going to zoom out. And this is my 1 whole. Now, my 1 whole tells me that which is 1 over 1 when we start this idea. Now, when we partition my whole into 4 equal parts, each one of these parts is 1/4. But if I have 4 of them, that tells me I have 4 fourths. 1, 2, 3, 4. I have 4 fourths, which is what you notice here is equal to 1 whole. Now, if I compare that to just 1/4, you can see that 4 of my fourths is going to be greater than just 1 of the fourths. So my numerator tells me how many of those parts I have. And so I have 4 fourths is greater than 1 fourth. Now that's using my fraction tiles or my fraction bars. If I wanted to show this on a number line, and I'm just going to zoom back in here. If I wanted to show this on a number line, I could put 0 and 1 to represent the 1 whole. And then I partition it into 4 equal pieces. So cut down the middle, that's 2 pieces. I take each one of those halves and cut it into 2 more parts, which means I'm doubling my halves into fourths. So I have 1, 2, 3, 4. This is 1 fourth. This is 2 fourths, which is also half, 3 fourths. And finally 4 fourths, which is 1 whole. Now, I can show you where 4 fourths is compared to 1 fourth is. And as you can see, 4 fourths on a number line is going to be greater than 1 fourth. So it still shows on the number line that we have 4 fourths is greater than 1 fourth. All right, let's take a look at our next problem. It's a line plot. And so listen carefully because this is going to be your discussion question for today. If you notice, it says use the information below to fill in the line plot. Now, each snake was measured at the zoo. And remember, on a ruler, and I'm just going to pull my ruler out over here, in between each whole number, we have half, which is right down the middle, or 2 fourths. We have 1 fourth, which is our next longest line, and 3 fourths. So 10 and 1 fourth, 10 and a half, 10 and 3 fourths, and then the next 1 fourth is going to be 11 inches long. So when they measured the snakes, each one of those snakes was measured and being represented as a number of snakes. So it says that 3 of our snakes were 10 and 1 4th inches. So each X is going to represent a snake. So I have 3 snakes that are 10 and 1 4th. I have 8 snakes that are 10 and a half inches. So I've got 1, 2, 3, 4, 5, 6, 7, 8, and that's going to take me over my title there. I don't have any that were 10 and 3/4 inches long. Also, we don't have any that were 11 inches long, but we do have one that was 11 and 1/4. So these were the length of the snakes, and the X's are representing the snakes, and that was their length. Okay? Now, my question or discussion question for today is, how many snakes were less than 11 inches long? Again, how many snakes were less than 11 inches long? How many snakes were less than 11 inches long? Okay, that is your discussion question for today. Our next set of equations has to do with using what we know about multiples of 10. In this case, we have one group of 90. One group of 90 would be how many objects? Well, of course, 90, right? And that's why we know that any time we multiply by 1, we have one group of that certain number of objects, right? And remember, these can always be switched. We can also use what we know about 6 groups of 9 to help us with 6 groups of 90. Now, how do we do that? Well, if we know how to count by 9s, which we should, right? Because we have 9, 18, 27, 36. Our next group of 9 is going to be 45. And finally, 54. Now, since we know how to count by 9s, then we should also be able to count by 90s by using what we know. So if we're adding all these zeros in here and we're multiplying by 10, so that means all my place values move to the left. My place values move to the left. So the 7 becomes 70 and the 20 becomes 200. The 6 becomes 60 and the 30 becomes 300. And the same thing, we continue. So now I can see that 6 groups of 90 is going to be 540. Now, I'm going to use a different strategy here for the third one. I'm going to break up my factor as 2 addends. And I'm going to use 80 times 5 and 80 times 4. So 80 groups of 5 are 5 groups of 80. 8 times 5 is 40, so we know that this is going to be 400. 4 times 8 is 32, so 4 times 80 would be 320. And whenever I add those up together, this is going to be 720. Now, I could check that answer by knowing what I know about groups of 8. So 8, 16, 24, 32, and I'm not giving myself enough room there, 24, 32, 32. So that's 4 groups of 8 so far, which has been 320, if you notice that. Then I have 5 groups, 6 groups of 8, 7 groups of 8, and finally 8 groups of 8. Let's see, what did okay, 0, 8, 6, 56, excuse me, that's my fault, 56, then 64, and then finally 72. And again, we're using what we know about counting by 8s to help us count by 80s, right? We're counting by 80s instead of 8s. So this is going to be 720. So just another way to get the same answer that we did here as here. Instead we broke this up as 9, but we also can count by multiples of 8 or 80 to help us. All right, that's it for today, guys. I will see you during our live meeting and hope you have a great day.